All right, so here we are looking at common FDPs, and in this case, we're just using those to shorten what we mean when we say fractions, decimals, and percents. And so we're looking at common equivalences of fractions, decimals, and percents. We know that we can go from a fraction number to its decimal equivalent number. We can go from a decimal back to its fraction. We can go from a fraction to a from a percent back to a fraction, from a decimal to a percent, and from a percent back to a decimal. And so we're just looking at some of the ones that are the more common ones. So let's get started. The first one that is very common is 1/2. And so 1/2 we can represent with a bar model, showing that in the bar we can split it into two equal sides, and one part of it is going to be shaded in. And so there's 1/2. The decimal equivalent of 1/2 is 0.5, and the percent then would be 50%. The next one we're going to look at is 1/4. 1/4 we can represent by making a bar model again. Notice here we have 1, 2, 3, 4 pieces that are equal size. One of them is shaded in. 1/4, or you can even call it a quarter, is the same as 0.25 or 25 hundredths. And so as a percent, it is 25 over 100 or 25%. So here's 25 for every 100, 25%. So the next one we're going to look at is 3/4. Notice that we can, again, shade in 3 of 4 pieces of a whole. 3/4 is equivalent to 0.75, and the percent equivalent value would be 75%, 75 for every 100. Next one down, 1/3. 1/3 is the same as 0.3, and when you put a bar over a decimal number, that means that that portion of the decimal repeats infinitely. So you might have noticed whenever you put 1 divided by 3 into the calculator, or 1/3 into the calculator, basically you end up getting 0.333333333 that continues on and on forever. It doesn't end on the calculator. It might look like it does, but that's just because you only have so much space on the calculator. Here, you end up putting 3 with the bar over 3, meaning that it actually continues on and on forever. And so 0.3, we can actually find the percent, again, multiply that by 100, then we end up with 33.3, but the 3 does still continue on forever, so we still put the bar over the 3 here. And that's 33.3%. Moving on down. The next one we have on the list is 2/3. As you can imagine, 2/3 is twice the amount of 1/3. So instead of 0.3 continuing on forever, we're actually going to end up with 0.6 that continues on forever. Since 0.6 continues on forever, we get 66. Just like 0.3, we get 33.3 continuing on forever. We actually get 66.6 that continues on forever. So we put a bar over that 6 there. Don't forget your percent symbol because that changes the number completely. Our next one is 1/5. Again, 5 pieces that are equal size. Only one of them is shaded in. We have 0.2, which is the decimal equivalent. And you'll notice here that we end up with 20%. 2/5, which would be double the amount. You can imagine then it would be 0.4 or 4/10. And then you can imagine then it would end up being not just 20%, but double the amount also, which is 40%. The next common one to look at is going to be 1/6. Again, 6 equal size pieces with one of them shaded in. Our decimal equivalent is going to be 0.16 with a bar over the 6, because that means that that 6 is going to continue on forever and ever. And here, since it does continue on, even though we don't see it here, we can imagine there'll be another 6 after it. That's how you can write 16.6 with the bar over the 6 here also. So 1/6 is the same thing as 16.6%, about 16.6%. The next common one is 1/8. 1/8, which is half of a fourth, would be 0.125, or 125 tenths, hundreds, thousands now, right? We're in the thousands place. So 125 thousandths. And from here, we have then 12.5%. And the last one that is a common one is 1/10. Okay. Notice here a way that you can draw this in. Since 10 is divisible by 2, I can draw a line right down the middle. And then I would need 5 on each side, so I can draw 4 lines inside to make 5 pieces, 4 lines inside here to make another 5 pieces. 1/10 is the same as 0.1, which is 1/10. Or we can think of it, well, here's 1/10, and the next place over would be 0 hundredths more. So a total of 10 hundredths, or 10 over 100. 10 for every 100 means 10%. 10 per 100.